had the solution for the previous one there. I think I kind of remember how to do the other ones, but maybe not. So I think I'll attempt to do at least some of this before I go back to studying this. And if I get stuck for too long, then I'm just gonna study these things here, try to clarify my mind. And I think I'll try to go for as long as I can focus now, which is probably gonna be anywhere between 2 and 3 hours. And then I'm gonna stop and probably read the book at some point, and then keep going. You're given the heads of two sorted linked lists. So this one, I remember the thing, you have two lists and you need to merge them. Return the head of the merged linked list. So while on left hand side, right hand side. And this was like this because of the previous time that I tried to do this. So now I think this one I remember. I had to see the value of them. If the value of the left is greater than the value of the right, and then you should make a different one, I think. Or I think it was something like this. And return dummy.next. I'm already tired from all the time I spent on the other one. So maybe if I create another thing here. Not sure if that's gonna change anything. Or maybe it should be okay, so never mind. So for some reason I'm missing the last value. Oh yeah, I think I have to do. So this is that done next, and then I have to check. And there was a smart way to check for that, but I forgot to check which one. I could do true if else statements, but there was another way. I guess I'll just do this way and then I'll look at the solution. Arteo, dollars. There was a smarter way to do this. I don't remember if I saw from this solution maybe is only here. Let's see.
Hey guys, it's me again, and let's solve
Or
another
just
LeetCode
a cleaner
problem,
way to do
merge
it.
two sorted lists. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're going to
Just
we're
jump
going
to
to
the
take the list
call.
one value and insert it into case, and you might be tempted to just L1, so we're just taking that one of them can be non-null. Works at 9%.
Also, it was probably somewhere here. On the... So how was it? Maybe it was... dummy done next. Oh. Was the other next equals left hand side equals right hand side. It was something like this. Let's see if this works. Yeah, but it's pretty much the same thing. I wonder if I can return this instead. Yeah, doesn't work. Yeah, whatever. Let me go to the next one. I think this one and the cycle one, I remember how to do it. And maybe this one as well. And the reorder list, I don't remember. We're given the head of a singly linked list. The list can be represented as reordered. The list should be on the following form. Oh, I think I remember this problem. Yeah, the ends should be in the middle. Yeah, so I think I remember that the first thing I have to do is find the middle. And you do that by advancing one faster than the other by one. And while fast and fast on next. Then you make it slow, it goes low on next. Fast, it goes fast, done next. And then this low will be in the, oh, actually, it's done next. So because the fast is jumping twice as fast as this low one is gonna be in the middle when the loop breaks, if I remember correctly. And then you have to merge them. We have to merge head with let me think. Because this low is gonna be in the middle of the list. The fast is gonna be at the end. Yeah, we have to merge head with fast. I think. With slow. So maybe a while slow. And then I create a new one. a new list, a merge. Yeah. Maybe the other way around is better. Oh, the thing is, I can only add one by loop. Yeah, I remember there was a problem here when merging them. So maybe I'll come back to this one after. Let me try a little bit and then, because the other ones I think I remember how to do it, but this one I don't remember really well. But I think I can try to append to this new one. New the next equals slow, and then new equals add, or new equals add, or maybe new, yeah, dot next equals slow. But I'm not sure if that works. Placing the add first, then after that I place the slow. But how much I have to move? So maybe I have to make new equals new dot next dot next. And just the amount of times I have to move them, I don't know if this is correct. Let me just print and see what happens if I do this. Or maybe it has to be the dummy because I'm changing the new each time. Hmm. Isn't that what I'm supposed to return? Oh no, I'm returning the same thing. So maybe let me print slow in the first one. Maybe it has to be slowed down next here. Because then it's gonna be at the tree. So new the next goes head. True, it's 3. But then I'm making head on next. Cosine. What you think is fine. Now let's see if this works. Oh, it's because I'm making the next here. Should make like this, and then probably. Maybe there's a difference when when the list is even or odd as well. That's the problem. No, I should begin at the end. That's the thing. And I'm beginning at the middle. Yeah, so I'll think about this one after I try the other ones. I think this part is correct. Or I have to fire in the middle first. I just don't know. Yeah, it should be. That's the only way. Because this advances twice as fast as the first one. Yeah, so I am at the value no true here, which is the middle. I just don't remember how to do the other part. So I think I'm gonna try this one first, which is pretty much the same as the other one. This should find the cycle, and I think this one I remember. Oh, I have to do this after I advance them. I think it was like this. Okay. Yeah, this one I remember because the mistake I was having the first time I did this was making the slow and fast different than the head, and then I was modifying them differently. So I remember this one pretty well. It's not worth spending time on it. This one I also think I remember because it was kind of similar. Because you have to advance one node nth times. Yeah, slow. plus add range and plus best on next. So here you advance n times the first nodes, and then you advance both of them. I think. Oh no, let me think. And then I think outside of this loop you make slow dot next equals slow dot next dot next. And then while slow dot next slow. Oh, maybe you just return here. Return slow. I don't remember really well, but I remember I have to advance one of them n times and then get them both to the end, and at that point re-reference the next one. But again, is the problem with the reference thing that I'm confusing, because which node I have to use and which node I have to change. There's a typo here. Yeah, that's the thing. I'm changing one of them. Oh, so maybe it should be had. But then that's the problem. If I change the had, I can't return the list there. Oh, so maybe it's while had done next. But then I can change. Because the one that is advanced is the fast by n amount. And so this loop I have to do it like this, I think. Yeah, create a new one. Because I changed the value of the first one. Because I can't, I don't think I can just do while head on x. Head equals head on x. I'm not sure if this works though. Because it's gonna change the value of the head. That's the problem. Again, same issue that I had with the previous one. About understanding which one I have to change. Or how to change the thing. As the logic is pretty easy, I think. Just advance one more than the other and then you remove the position. It's just about understanding how to change the node without changing the whole thing. Maybe if I made a reference to this, if I make tail equals low, something like that. Let's see if this works. What I have here. And then I return tail, donuts. Maybe this works. Yeah, there we go. Hmm. So this is happening because in this case it's the first one, but it might be the last one. But what am I supposed to return here? Maybe one easy way is I can't know actually the length of the list. But I also think I have to change this here. What? Oh, I expected to return nothing. Turn on. Or but I also think I have to change this one because yeah, when is the last one? Or it's out of there's no which points. Or when the index is out of range. So maybe if it's low, if it's lower than that. Why is expecting true here? Oh, it's because it's from the end to the beginning. Alright, so fast is gonna be equal to none in this case. That's the problem. So maybe it's just while fast instead of fast on X. Yeah, what do I do if maybe if I just remove fast on X it's gonna work, but if it doesn't then I'm not sure. So maybe I should be n minus 1 or n plus 1. Yeah, it doesn't work. Maybe now it works. Hmm. That's another problem. I have a feeling just end here, and the problem is this loop here. Because if I do fast on next, then it's gonna screw up the other one. And because it's supposed to count from the end of the list until the beginning, the issue is when this becomes none. And then this doesn't run and slowdown_x becomes no. Maybe I should put else here. And then well, what if I put if fast done x, or no, it can't be fast done x. Yeah. What does it mean when the fast becomes none? Yeah, that's the thing. It can be because it's starting from the beginning of the list. So it means that the length of the list is equal to n minus 1. So how can I remove the first one? What I'm thinking here, but I know that's not the solution. At least from what I can remember from the previous one. But I don't think this is the best, even if it works. And now it's returning 1, 2. I wonder if it prints here though. It doesn't. So it's going through here. But why doesn't this remove the first node? So maybe I should make this equal to this, but then it's gonna be the same thing. Oh, he's expecting. Maybe I don't need to do this then. Oh no, because then it's gonna return one true. Yeah. So yeah, I have to change the value of the load.next equals none. Something like this. But I know this is not the solution, even if it works. That's the problem. Yeah. So scratch this. It has to be something else that I'm missing. Maybe it starts at 1 here, but I also feel like this is not gonna not work. Yeah, because now I'm removing the fourth one. The last one. And if I return tail.next, it's not gonna work as well. So I'm starting at the end. So fast is gonna be none. Fast.next is gonna be none. Because it goes 3 times. Maybe I should print this. And I have to submit because that's the case I'm interested in. And then it's gonna skip this. And it's gonna make us load on next, equals load on next on next. which in this case is gonna modify true, and it should be modifying 1. So maybe I need to make it low equals to next, the next. And maybe the other way that I was trying to do, but for some reason I don't think that way is gonna work. Fast and fast on next, I do this, and then I also make slow because it's slow on next. Slow down next, or slow. But I don't think it's gonna work as well. Right, then it's the same thing. Oh, because I'm making tail equals to head equals to slow first, and this doesn't modify anything, then when I return, I think that's the problem. You didn't modify this one, but it modified this one. What if it returns low here? Yeah, but that's also probably not gonna work. Yeah. Let's see if there are any others that, just this shoe. And this one I vaguely remember, but I'm gonna leave this one for last because it's hard. But I remember you have to separate and do that recursive thing. Because I spent a bunch of time on this one. So maybe I should try to study this stuff and understand before I keep trying to do the other one. The problem here is only, I think, when n advancing n makes fs.next equals no or none. And I think that only happens when n is equal to the length of the list minus 1. It has to be the case, I think. But maybe not. Maybe I'm confusing something. Maybe I don't need to do this stuff and just return head here. It's the same thing. Maybe? Yeah, yeah. I have a hard time understanding why changing slow changes head as well. I know. I think it's because of the reference. You're making slow to be a reference of head, so when you change, it's like the difference between copy and that kind of stuff. So when you change slow, it's gonna change head by default because the slow is just a pointer or something like that. And I think I understand those concepts when it comes to variables, but in this case, it's really hard to think about it when it comes to the object, because the object is more complicated because it has all the other references inside of it, and a variable is just a variable. And here also I have to think what do I do if I get there, and like how do I remove the first element? I'm thinking that maybe I should put this here and then make it fast or nice. I do something. Oh, but actually no, because I'm advancing them, so it's always gonna be none at this point. And if I do next return uh, I don't think this is gonna work, but let me just see if it gives me a different output here. So I'm supposed to return the second node. So maybe I just return add.next. It's gonna work for that one, I think. Okay, nice. Let me see, but I'm really almost 100% positive that this is not the solution from the other guy. But at least I was able to get it, so pretty happy about that.
Hey everyone, welcome back, and let's write some more neat code today. Today let's solve remove nth node from the end of a list. So we're given a linked list, and all we need to do is remove the nth node from the end of the list, and then return the new list. So that's pretty straightforward, right? So in this case, we got 5 nodes. We just want to remove the n equals 2, so meaning this
We're just gonna go for the code,
to dummy equals until right reaches the
I already know the explanation. Oh, I think in the book, yeah, that's probably where I saw the different solution I was thinking about for the other one. I think merge should link to this because the book has the same challenges that this list has. So far, I didn't like the book that much. It's good, but I didn't like it that much because it's pretty redundant from the parts that I read. It's pretty much just the same problems, so not sure if it was a good decision. But there are some additional stuff there that is interesting, but I was looking for a different kind of book, and it's still am. In some sense, I want a book that talks more about this stuff here, about these references and the understanding the computer and what's going on. Because I think that this helps me the most to think about these problems, I think. Knowing what's happening, and also execution scope and stack frames, stuff like that. It helps a lot more. And that's the kind of book that I'm looking for, outside of the list of the ones that I already have there.
We know that dummy.next is at the head of our list, which is what we want to return. We want to return the updated list, so we can just return dummy.next. We don't want to include our dummy node in the output. We never wanted to add a node to the list. We just wanted to remove a node.
So why this one works and the way that I was doing doesn't work? Because it's pretty much the same thing. Oh, maybe it's because I was putting fast next here. Yeah, but I also think it's because of the way he initialized here. That's the difference. But they're both equal to the head. But this one is equal to the head by reference to the dummy. Yeah, that's the difference. because I was changing the dummy and returning, but it's pretty much the same thing because I was returning the tail, which I made it equal to the dummy. And he is also returning dummy.next, and I was just returning the tail. So maybe that's the difference. Because I was checking for fast.next and returning the dummy, the node, and he was returning the next one. Maybe I should try to rewrite this one to see. So going from the stuff I had before, let me see if I can change this one. Should work there. So this part I think is the same as here. Then while fast, advanceable. And then this is tail.next. Next. And then this thing here, didn't do this. Yeah, now it should be the same, I think. So if this is wrong, it means that, yeah, is this initialization here that is incorrect. But what's the difference? That's the thing. Because it would be the same. Oh, it's because it makes it equal to the... Oh, but it's the same thing. Actually. Is my case low is equal to dummy. So maybe I should be returning slow here. Yeah, that's the difference. Because it's changing this one. And it's still incorrect. Isn't it the same thing? What am I missing here? Maybe if I write it down in the same line, it's gonna be easier to see if it's the same thing or not. Because the only thing that changes in my mind is the name, but I'm definitely missing something. Okay, so tail is slow. Dogs fast equals ahead. It advances until it reaches 0. Or maybe this is the loop that's different. It's changing the tail. It's exactly the same thing. So the only difference is the loop. What if I do +1? Yeah, I don't get it, man. There's something that I'm missing here. How can I search or study for this stuff? Yeah, doesn't work. So what else can be wrong here? The only difference now is this thing, I think. Oh, maybe that's why. It's because when he does it like this, the difference is making a copy. And I'm modifying the original one, I think. Let's see if it works. Yeah, that's why it's different. Because I thought it was the same thing, but it isn't. That's why I'm getting confused in these challenges all the time with the linked list. Because I have to remember that when you make it equal, you make a reference, you're gonna change the original one. That's why it's different. And it's not that complicated, but it's confusing. Again, this one I'm not sure if I'm gonna be able to do it because I don't even remember really well. I think the logic was to make one, and again, I think the issue I'm gonna have here is think about these references. They're gonna confuse me. But I think you get one list into the middle and you yeah, one list is the end, the last half, and then the other list is in the beginning, and then you merge the two. This can be represented as this, or the list should be on the following form. So is it the beginning with the end? Also, you need to reverse it as well. That's the thing. So you need to get it to the middle, reverse it, I think. Which is gonna be really complicated based on the amount of time I spent on the first one. And then you need to merge them. Okay, so let's remember how I did the first one. If I can't do it, then I'm gonna look because, yeah. So I don't spend a bunch of time. But I'm definitely gonna study. My plan is just finish this one and then study the stuff before I go into the hard one. But I have a feeling that the hard one is not gonna be as hard as the other ones because it's the one that I spent most time with the first time, but it might be just as hard or harder. So I don't know. And the one that I have to reverse is the slow one. So you make it equal to the head first. Then you need, maybe I should do this after this. Then you need the previous one equals to none. Rev slow. And next equals current dot next, which should be rev slow. Maybe I should just go with rev or reversed. Rev dot next. Yeah, now now it's gonna be the problem. And then I need to make previous equals had. Previous equals low, actually. Because I'm trying to reverse this low. And then rev dots, or this is low dot next. Yeah. Because in that case it would be head. So it's low dot next. And rev dot next equals prav. So let me think. So I'm storing the next on this variable. And I'm making the first one equals to this one. Then I'm making the next equals to the previous, which is none. But it shouldn't be none. It should be slow. That's the thing. And this should be slow as well. Or maybe it should be none actually. And this should be slow. Because I want the last element should be pointing to none. And so the next one points to none. Then the previous one points to the next one. Which is low dot next. Maybe it is correct. I just don't remember below. I need to see if the reverse is gonna be equal to the inverse there. Maybe I should print slow and then print reverse to see if it's doing what I think it's doing, what it should be doing. Okay, so it's low is 1 true and I'm getting none. And because it's only one element. But it should be making. Yeah, but what if it's just one node? Then you can't reverse it. And why is low just one node though? Oh, it's because I'm changing the value here. That's why. Oh, so it's low that is gonna be previous, I think. No, that doesn't make sense. Isn't this correct though? Oh, and the issue is if I modify is low, then I can't. Oh, actually, I have to modify is low because I'm gonna merge with the head at the end, so it doesn't matter. But again, I'm stuck at the same point that I was stuck at in the first solution. The only difference is now as low as the head. Yeah, it should be the head because it's the one in the middle. And I have the variable. Maybe I should make it the same names so I remember. It's easier to remember. Oh, so this was current on next, I think. Yeah, so maybe that was the mistake there. Oh, but I'm outputting 1 inch. Why though? If it's not printing that. Again, same thing. I'm making the first value equal to the next one. Or maybe this has should be slow down next. And current down next goes previous. Yeah. I still don't understand the other one. Even though I made it. I don't know why though. It's so weird. That should be because of the referencing thing, but I think I'm just gonna look at it. Otherwise, I'm gonna spend too much time. But it sucks though. I need to figure, because this way then the problem is I'm still gonna have the same issue.
Hey everyone, welcome.
I need to figure out what's
Back,
making
let's
this so hard for me to understand. Oh, this is a different thing. Oh, this is with recursion. I'm not even gonna worry about that now. So let me see the difference from this one to the thing that I'm trying to do. Okay, sad, current on x equals previous. Previous equals, oh, I'm making equals low. Should be equals to current. But the rest, I got it correctly. Maybe it's the way that I'm thinking about the conversion.
result, which we know is stored in previous when this loop stops.
Because I'm thinking that the result's gonna be stored in current, but it's supposed to be stored in previous.
Executing. So it works, and this is actually the most optimal
I think that's what's messing
the
me
time
up there.
complexity is big O of n.
Because I'm thinking about changing the current so it's reversed, but he's using the previous. He's using the current just as the node that is the bridge between the two. That's the problem, I think. It's still very confusing. It pisses me off. Let me see. Let me run and see if it worked. Okay, now it's reversed. What can I do to remember this? That's the question. I don't want to remember. I want to understand. But it's really hard for me to. It's just that it's confusing the fuck out of me. When it's changing from one to the other one. I need to spend time trying to understand what I'm getting. What is making this so difficult for me to understand? So next is gonna be slow down next, which is the second node. Then it's gonna make the current equal to the second node. And it makes the... Oh, so it's passing the second value into the previous one. And then it's making the previous equal to the current. That's the issue here, I think. And that's the reason why I had the realization about the assignment stuff. I think that's the key here. Because when it makes... Oh yeah, now I remember. It was the same thing that I felt the first time that I saw this. Because when it makes previous equal to current, it automatically reassigns the value of the next, and that's what's confusing. Because current on next is the second node, it makes it equal to previous, which is none. Then makes previous equal to the current, which is the head. And maybe I can put this... And the problem with using Python Turtler is that I'm gonna have to use to create the classes here. And to create the list manually. But maybe it would help if I could see the execution, so maybe it's worth it. I think I'm gonna do that actually. Because this is so confusing to me. Current on x equals previous, which is none. So make sure equals none. And then it makes the temporary variable equals to the next one. And this is why I think it's confusing, because it's using two different nodes, I think. Yeah. I'm gonna try to finish this one and then I'll think about it. Or maybe I'll think about it later, after I search the videos to study this. Okay, so now I have to merge this previous with the... well... With this low? No, with the head, I think. And then maybe I need another two variables. One to store the result and one to change the values. Or I just make a new one. Cosad. I don't know if this is gonna work. Probably not. Or am I modifying that? Probably not. Just print this. And that's another thing. But that's fine because I only need the first true values anyway. So I think that's fine. So even though this stuff here is modifying the head, I think. Yeah, I'm not sure which one is modifying the head, to be honest. Maybe I should print here as well. Just see. Print head here. But I guess it's gonna be this one that changes the head. Oh yeah, I forgot to show. Take this off. Yeah, so it's this one that modifies that. I was wrong. Because I'm changing the slow and then slow. Is equal to the head. Yeah, I have no idea. I guess when it makes screen.next equals previous, it modifies the head. Or it just wipes out the head actually. Because slow is equal to the second half of the head. And because it's changing that second half, it changes the references. I think that's what's happening. Yeah, but that's fine because I only did the two first values. So if I make res.next equals previous, doesn't that connect the 1 to the 4 formal? I print rev here. Or equals prov. Oh, and this is gonna run into an infinite loop. Oh, I'm not making res equals res.next. That's probably why. Oh, but then I'm modifying. That's the problem. Because then I will have to create a different node to keep track of the values. I don't know. Oh, it's because I'm modifying the head again. Maybe if I do list nodes and then do it like this, then it works. But maybe I'll have to create another one as well to change the res using the other one. Let's see, res.next equals to previous. And then equals to the head. So this should go until one of them reaches null. Okay. So at least this doesn't go forever. And previous is the reverse. Oh, but it's missing. I'm missing the fourth node as well. Maybe it's because I'm making it equal to none here. But yeah, it shouldn't be because the first value, the last one has to be none, and the first value should be the fourth. I'm gonna print slow here. Alright, slow contains the fourth one. So it should be on this switch here. So maybe this should be only slow. Yeah, but then I missed the next one. Because I guess the difference between this one and the other one is that the other one you can start in the second position, but this one you have to start where you stopped because it is exactly the middle. And the other one, the first position is going to be 0, I think. But maybe not. It's the thing, I have to use the next here. Because otherwise I'm just making store the same value here. I think I'll have to look at the solution. I'm not gonna be able to do this. Even if I spend a bunch of time, because there's this stuff that is confusing me. And even if I get that stuff right, I don't know how to do. I know how to do. I know what to do here, like the logic. You stop in the middle and then reverse the middle, and you merge the two. But I just don't understand. I think it's better if I look at the solution than I study this stuff here. And I have to find a way to, because it's not easy to define what exactly is making this a lot harder for me. That's the problem. I guess I think it has to do something to do. It has to be something related to references in the objects, but I'm not sure how to search for that. To find for things that will help me understand better or think about it in a better way. Maybe I'll try half an hour more, and then if I can't, but it's already late actually. I think I'm gonna look and then I'm gonna study this stuff. What I'm gonna do, I think, is keep studying this stuff and doing the list
Hey
until I
everyone,
can
welcome back.
these
And let's write
exercises
some.
until I can remember, not only remember but understand exactly how to think about it.
More neat code today. So today let's solve array position end. But if we're not putting this in an array, how exactly can we do that? Because we're going to have one pointer at the beginning of the first array. We're going to have one pointer at the end of the second. I think I said array, but what I meant is list, obviously. We're going to have two lists. And so the first half of the list is going to be straightforward, right? We're going to take, this is going to be the node that goes at the beginning. Then we're going to take this pointer, shift it to the right. So that's pretty straightforward. But since we have a pointer at the end of the second list, and we take this node, we put it in the second position, right? We'll insert it somewhere in the middle over here. That's not impossible, right? We can do that pretty easily. But the problem becomes, okay, once we've inserted this node, then we want to move our pointer to this node, but the link is going the wrong way. The link is going in order, but we really want the link to be going in the opposite order, because when we traverse this second portion of the list, we're not going to be going from beginning to end. We're going to be going from end to beginning. So how can we do that without extra memory? Well, the easy way is, why not just reverse the links, right? For this entire second portion of the list, why don't we reverse every single link, and then we can do it pretty easily, right? There's no reason that we can't reverse the links. We're perfectly free to do that. So that's kind of what makes this problem a lot easier. There's going to be two phases to this algorithm mainly. We're going to take the second portion of the list, reverse it, and then we're going to take these two portions of the list and merge them together. This first, next this value, then this, right, et cetera, et cetera. The only other thing that I want to mention is when we're reversing the second half of the list, how do we know what is the second half? How do we know we've reached the second half, right? Starting from here is when we want to start reversing. How do we know once we get there? You can do it multiple ways. The easiest way is going to be a fast and slow pointer. So I'm going to have the slow pointer initially at the first and the fast pointer initially at the second node. We're going to be shifting the slow pointer by 1. We're going to be shifting the fast pointer by 2. And we're going to keep going until the fast pointer either reaches the end of the list or reaches the last value of the list. And once that is the case, we know that the slow pointer is going to be, if it's an even list, you can kind of run through it yourself and see that it does work. But if it's an even list, the slow pointer will be at the halfway point pretty much, right? It'll be at the end of the first list, right? So then what we'll do is say, okay, slow.next is going to be the beginning of the second half of the list. So that's what happens if we have an even number of nodes. What happens if we had a odd number of nodes? Let's see if the same thing works out for us. So if we had a slow pointer here and a fast pointer here, we'll shift the fast pointer by 2. It'll be over here. The slow pointer will be over here. Then we'll shift the fast pointer by 2 again. So it'll be at null over here. The slow pointer will be at this node. So I guess the question becomes, what in this case, what's the second half of the list? Because obviously we have an odd number of nodes. Well, what we're going to say is this is going to be the second half of the list. Even though it's shorter than the first half of the list, it still works for us, because what the result in this case is going to be is basically, we have this second half of the list. This is the first half. We're going to take 1 at the beginning. We're going to take 5 in the next position. Then we're going to take 2 in the next position, right? We're just basically alternating. Then we're going to take 4 at the next position. And lastly, we're going to take 3 in the next position. So it does work out in this case. So you can see that, finding the middle of the list is something that can be done with 2 pointers, one fast and one slow. And in terms of actually taking these lists and merging them, it's pretty straightforward when you look at the picture. Actually coding it is a little bit tricky because we're going to have several different pointers. But just to give kind of the rough idea, we're obviously going to have a pointer here, which is going to be the beginning of the first list. We're going to have a pointer here, which is we're going to call the second pointer, the beginning of the second list. Obviously, the link here is going to be going the other way. What we're going to do is we're going to take, okay, this pointer dot next, right? 1 dot next is, instead of being set to this node, we're going to break this link, set it equal to the second node, which is 5. And then, of course, 5 is pointing at this node 4. So instead of having it point at 4, we want it to be pointing at this node, which was the original next node for 1. So we're going to do that. 5 is going to point at the second node. And then we're going to shift our pointers. We're going to take this pointer, set it to 2, take this pointer, set it to 4. Now, obviously, notice how we broke the link in both spots. So how are we actually going to be able to shift the pointers if we broke the link already? Well, we're going to have to save that link before we actually break it. We're basically going to have a temporary variable, which is going to point at this node, and a temporary variable that's going to point at this node before we actually break these links. I think that'll make more sense when I actually code it up, but that's basically the idea. And obviously, these 2 pointers, we're going to keep shifting them until they basically meet each other. And actually, one last thing, notice how the first list, so when we actually cut this in half, once we actually have a first half and a second half of the list, for the last node in, we can jump in and remember the first non-null and have to reverse the second half of the list. Before I reverse it, I'm also going to this line, previous, is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next. But before we actually shift our pointer, we're going to say second.next.
Oh, now I remember, I think, that he makes another loop at the end. Yeah, but it's really confusing. Just creating 2 different pointers after.
Next is going to be equal to previous, which is initially going to be null. And then, of course, we're going to update our pointer. So now previous is going to be equal to second. and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the two halves of the list. So the beginning of the second, right, we want to find that beginning of the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list, similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second is going to be whatever happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the two lists. And so we're going to keep going until one of the pointers is null, and we know that the second half of the list could be shorter than the first half, so we're just
So his second here is my prev, or my current. But I think up to this part is pretty much the same thing. The difference is makes prev because it's low dot next. Because no. And also current is low dot next, not slow. But it doesn't seem like it's working here. Because it's missing the 4 in the previous. So it's something else that I'm messing up there. So slow next, okay. Oh, here is current. That's what I'm messing up. Yeah, that's the problem, I think. Second on next. It's previous equals current. Current equals next. But I also think, okay, now it works. That was the problem. Hmm. And then here, I remember now I made 2 different variables as well for this one. But I don't remember really well how to do it also. I think I'm just gonna watch.
While second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing.
Yeah, 1 is equal to the head, which is this one, and the other one is the prev. But he creates another variable to point to that one. Don't understand why. It makes like this. Or maybe it's because it's gonna change the. He's gonna change second in the loop, and then he wants to return prev. Maybe that's why.
The next nodes in temporary
variables. Oh, and then you have to do another 2 temporary variables to pass. So it's the same logic from this one, but with 2 temporary variables instead of 1. Or maybe it isn't the same logic actually, but it's a similar thing. Temp 1, temp 2. I guess this would be dot next and second dot next. I'm not sure though.
we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers. So we can say, okay, first is now going to be set to temp1. Second is going to be set to temp2. And we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient.
God damn. Yeah, so it makes first, it's the same logic, but with two different variables. But it's extremely confusing for me. And so it's making temp1 equals to first.next, then changing the value, and then making second.next equals temp1. Yeah, I need to think about a way to study this, to improve the way that I'm thinking about it. It's hard to find videos though, or to find ways to
10
search
times
for
faster
videos.
than the code on the bottom. Watch this video and find out. Today we're starting a new series on data structures and optimization, and we'll start by talking about arrays, or the array data structure. Having an understanding of what's happening under the hood is super important for performance, so we'll be going into depth on what arrays are, the cool things your computer does to make things faster. We'll talk about why arrays are fast and when they're not, and if you stick around to the end, we'll talk about how this fits into what's coming up next. What are arrays? To put simply, they're a way of storing several items at once. Typically in code, you'll have a situation like this where you want to store some random crap. I might want to declare some items like float prices equals 199, 299, etc., etc. This is the C++ syntax. Or in JavaScript, it'll look something like const price equals 199, 299. You get the idea. Now here in the code, prices is my array, and I've got 3 items in the array. And generally, the property of arrays is that you can look up individual elements in the array by their index. Typically, arrays are 0 indexed, meaning the first element starts with index 0. So if I want to refer to the first element, its price is at 0. And then the second...
Until I get this correct in my mind though, I'm not gonna move to the next topic, I think, because it's pretty important to understand. It's something that is basic, but for some reason is really hard for me to understand. It's just confusing me a lot. All these reassignments and temporary variables, it makes it harder for me to think about it. I think I'm gonna watch this video here and then I'm gonna watch this off stream. I've seen some of the free code camp videos from this guy, I think, and they're pretty good. I like the explanations. I saw one in recursion, was really good. So if it's the same style, it might help me understand. The issue is I think I understand what's going on, but it's hard to come up with the solution because it's confusing when you're thinking about creating these pointers and how they're gonna change the original object. I don't know. So maybe watching videos is not gonna help. That's what I'm concerned. Because usually videos, they're just talking about how it works, but
the operating system
is prices at 1, and so on. What does this have to do with memory? So now, when I talk about arrays, I'm going to be talking about them in the sense of C++ or C# or a language like that, where they're the exact same type of items, be it an array.
this is not related to the thing that I'm studying. So maybe I should spend some time trying to understand what's going on here. I think I understand but being able to think about this is a different story. He's creating two variables to hold the next value of each list. Then he makes that value equals to the first one, to the head. And second dot next equals to the first dot next. To head dot next. It makes first and second equal to the next. Yeah, it's the same, pretty much the same structure from this one. But this one, he's merging the two, and this reversing.
Because we're not using any extra memory and we're doing this in linear time. We are iterating through the list, I think, twice, but that's not too bad. So I hope that this was helpful. If it was.
Oh, and then he doesn't return anything. Huh. So he makes head dot next equal to the previous one, which is the reversed. And then second dot next equals temp one, which is the head. First and second temp one. Yeah, I'm not sure. I'm gonna have to spend a lot more time reading that. I think I'm gonna stop here. I'm already tired and I can't think about it anymore. But it's gonna take me a lot more time trying to understand this solution here, to wrap my head around this. It's not that difficult, it's simple, but it's confusing, and that's the problem. Because I need a way to make this intuitive for me. Otherwise, every time that I have to do one of these problems, I'm gonna have to spend a bunch of time thinking about this. About how the pointers are gonna change the original one, and then it becomes a mess. But I think what I'm gonna do is next time I'm gonna try to do the same problems as well. I'm gonna mark this. Except this one, I think this one was the easiest, and I remember what to do. The ones that I'm having difficulty with is the ones that I have to change the values. Or, yeah, change the lists. Because then we have to change the references. Merge the two is also not that difficult, I think. These ones are the ones, and maybe this one actually. So maybe I'll just redo this two here until I get it. Because this one was kind of hard, but it's not the same thing, I think. Let me see if I can remember, maybe. I'm gonna erase this stuff here. So I'm either gonna spend a bunch of time trying to get this shoe right, and because the problem is I have to study other stuff, so I can't spend forever on linked lists. So if I'm able to understand it fast enough, then I'm gonna try to do other problems. But if not, I'm just gonna spend I think 1 week or so trying to really understand how this works before I move on to the next topic. Oh, and here I just realized they don't ask you to return anything as well. Modify the hiding place instead. Oh no, this is the same one. It's this one. This one they ask you to return. So let me try this one again. So you have nodes. Equals add, previous equals none. While current. Return next. But now I think I'm gonna remember by memory. It's not the same thing. Equals to previous, maybe. Previous equals to current. Then return. Next. Something like this. Bruv. So I remember, but it's my memory. It's not the same thing. I need to spend a lot more time. And then if I get stuck tomorrow as well on these two different problems, I'm gonna study more, I think. Or I'm gonna think about different ways to search for this thing that I'm having difficulty with. And then I'm just gonna study that. So, see you next time, or yeah, next time that I come, maybe tomorrow or some other time. So, see you.